Okay, so this is a calculator aid for hypothesis testing of means, and this is when we have a dependent sample. Often when we do dependent samples, we often encounter before and after studies. That is the most memorable example of a dependent sample. So we're going to use a before and after study in this example dealing with deer population. Now, in hypothesis testing with dependent samples, we use a t-test. Step one for your calculator, no matter which calculator you have, and even if you're doing it by hand, you need to calculate the differences first. And then if you're doing it by hand, of course, you have to get the d-bar and the standard deviation of the differences. Sometimes maybe that information would be given to you, and in that case, with your calculator, with your grapher, you'll want to use statistics rather than raw data. But what I've done is, let me go into the statistics menu. I've entered the data into my calculator into list 1. I've entered the difference data, and it's very important to note, if you have a negative value, you use the negative key for negatives. Don't use the minus key. Your calculator, depending on the year and the make and the model and everything, usually it'll get it very confused. So it likes the negative key. So make sure if you have negative values, you're using the negative key. And again, I've just entered this data directly into list 1. So let's go here with the 8384. Once you have some raw data entered, and again, you can use statistics if you want, but we'll go to the stat menu for a hypothesis test. I've set up the hypothesis, the null, and the alternative already. The differences are 0, meaning there is no difference, and less than 0, meaning there's been a reduction, or the population has dropped, because this was with population, so there's been a reduction in population in this example due to the highway. So we're just going to go to test, and we want t-test. It's one sample. I know it seems like it's two samples because there's two lines here, but it's one sample because we're just using the differences, okay? It's dependent samples, so it's one sample, and this one's a before and after study. Now, instead of statistics, I'm going to select data, and when I do that, notice mu naught is still the first thing that's prompted, and we're just going to enter 0, meaning there is no difference. And the list number, it says, what list are you using for your data? Well, I stored my data in list 1, and so you would enter whatever list you stored your data in. And frequency is 1 because I did not stack my data or anything. The symbol in the alternative is a less than symbol, so you make sure that's selected, and then you hit calculate, and this will give you your appropriate p-value. Our p-value is very large, 0.9959. So in this scenario, we will, of course, p is definitely going to be larger than alpha, and we will fail to reject. The null hypothesis. Now, I did this one by hand earlier, and this is the test statistic. The t is the test statistic. So if you're wanting to do the critical value method, you can still use this calculator to help you out. It's going to give you the test statistic, and then you would look up the critical value, the t value, in your table. Okay, so it still cuts out a lot of work for you. Or you can use the p-value method. So that, it also gives you x bar. FYI, it gives you x bar and sx, meaning the difference, the mean difference, and the standard deviation of the differences. So this is a good way, if that information is given to you with the raw data, for example on an exam or something, you could check to make sure that you didn't have a data entry error that way. So keep that in mind, and this same process for the 84 pluses as well. Next video I'm going to teach the 89 titaniums, and that should pretty much wrap it up for one sample hypothesis testing.